The addition rule for probability takes on two slightly different forms depending on whether the two events that we're considering, E and F, are mutually exclusive or not mutually exclusive. If our two events, E and F, are mutually exclusive, then the probability of event E or event F is the probability of event E plus the probability of event F. If the events are not mutually exclusive, then this formula starts off exactly the same. Probability of E plus the probability of F, but then we need to subtract out the probability of E and F. Essentially what we're doing is making sure we're not double counting the overlap between those different events. We'll take a look at some examples with this. In example 3, if you draw a single card from a standard deck, what's the probability that you draw a spade or a diamond? These two events are mutually exclusive because a card can't be both a spade and a diamond. So to find this probability, we find the probability of drawing a spade, which is 13 out of 52. And then we add the probability of drawing a diamond, which is also 13 out of 52. Add those together to get 26 out of 52, or 1/2. So we have a 0.5 probability, or a 50% chance of drawing either a spade or a diamond. In example 4, if you draw a single card, again from a standard deck, what's the probability that you draw a diamond or a 4? These two events are not mutually exclusive because there's a 4 of diamonds, so there's an event that occurs, an outcome that occurs in both events. But to start, we'll take an approach that looks similar to what we did in example 3. We'll find the probability of selecting a diamond, so that's 13 out of 52. And then we'll add the probability of drawing a 4. We have 4 different suits, so there are 4 different 4s that we could draw. Since these events are not mutually exclusive, we need to subtract out the probability that the card we draw is both a diamond and a 4. There's only one 4 of diamonds, so we're going to subtract out 1 over 52. And again, what we're doing is just subtracting out the overlap between those two groups. There is one card that exists in the 13 out of 52 and the 4 out of 52. So subtracting that helps us not double count that card. So this is going to give us 28 over 52, or a probability of approximately 0.3077. In example 5, we again draw a card. What's the probability that you draw a spade with an even number on it? These are not mutually exclusive because there are even numbered cards that are spades. But we know we have a probability of 13 out of 52 that will draw a spade, plus a probability of 20 out of 52 that will draw an even numbered card, since those would be the cards 2, 4, 6, 8, and 10, and they occur in 4 different suits. Then we need to subtract out all of the even numbered spades. So we have 5 options there. The 5 even numbered cards that are spades will subtract 5 out of 52 to get 28 out of 52, or 0.5385. We'll look at one more example of drawing from a deck. What's the probability that you draw a king or a 3? Now we're back to a situation where these are mutually exclusive events. a card can't be both a king and a 3. So we'll just find the probability that we draw a king. There are 4 options out of 52 cards, plus the probability that we draw a 3. There are 4 3s out of the 52 cards. So we get 8 out of 52, or approximately 0.1538.